Now, as we can expect from any project, what happens after a while? After a while, the customer wants something different than what they had asked initially. And now Mr. Johnny Hurricane, the CEO of Weather-O-Rama, is called, and they say that they cannot possibly ship without a heat index display element. Long story short, they want a new display that will show, that will illustrate the heat index, which is something different, which is calculated using the temperature and the relative humidity using a certain formula. Now, it is not important what kind of formula we use or what exactly we show. What is important is that they want a new concept shown by the display elements. So the question is, how easily can we accommodate this? How easily can we integrate this into the project, into the design? So we wanted to look something like this. So basically, we wanted to show not only the temperature, the forecast, and so on, but also the heat index. So where exactly are we supposed to plug it in order to play? Now, there is a very important concept here now concerning the interaction between subject and observer. And that question is the following. Should we pull the information, or should we push the information? Now, what exactly does it mean to pull and to push? Basically, the idea is that there is a certain information, certain pieces of information inside the subject class, and the observer has two options. Either the subject will send it, either the subject will send to all the observers the new data, the pieces of information. So that would be the push strategy. Or the subject will only let the observer know that there has been a change, and it is the observer that will pull the data, that will actually call some methods, execute some methods from the inside of the subject and select, pick only the parts that interested. İki farklı yaklaşım var arkadaşlar. Subject ile observer, yani konu ile gözlemci arasındaki etkileşimle ilgili. Biri pull, biri push, yani biri itme, biri çekme. İfade ettikleri de ne? Ya subject'ten, yani abone olduğumuz yayıncıdan, konudan gözlemciler veriyi kendileri çekecek ve dolayısıyla da sadece ihtiyacı olan kısımları alacaklar. Veya alternatif olarak subject observer'lara ne zaman yeni veri varsa hepsini verecek paket olarak. Çünkü sonuçta subject bilmiyor kimin neyle ilgilendiğini. Abi diyor benim elimde diyor 3 parça veri var veya 4 parça veya 5 parça. Al diyor 5'ini de ne halin varsa gör. Ha sen onların belki birini kullanırsın, belki ikisini. Ben onları veriyorum sana. Şimdi hangisi iyi, hangisi kötü? Hangisi bu yaklaşımların iyidir, hangileri kötüdür? Should we use the pull strategy or should we use the push strategy? Let's look at the opinions. The observer says, don't be so pushy. There's so many different kinds of us observers that there is no way you can anticipate everything that we need. Bizim diyor ihtiyacımız olabilecek her şeyi diyor senin diyor öngörmen mümkün değil diyor. Bırak diyor biz sana gelelim, ihtiyacımız olanı alalım. That way, if some of us only need a little bit of state, we aren't forced to get it all. So for example, you expand yourself and add some more state. Well, if you use pull, you don't have to go around and change the update calls on every observer. Eğer yeni şeyler eklersen içeriye paylaşmak için gidip de diyor herkesin update yöntemini güncellemek zorunda kalmayacaksın. Diyelim ki 100.000 tane observer sınıfı var. Tabii abartıyorum şu anda. Hani gidip 100.000 tane sınıfın update yöntemine abi sende temperature, pressure, humidity vardı al sana 4. parametre demek zorunda kalmayacaksın. Eğer pull stratejisini kullanırsan. All you have to do is just change yourself to allow more getter methods to access our additional state. Sen sadece get yöntemlerini ekle diyor. Biz diyor değişiklikten haberdar olunca geliriz istediğimiz get yöntemini çağırıp arzu ettiğimizi alırız. En azından iddia ettiği bu arkadaşın. Subject ise ne diyor? Yes diyor. I could let you pull my state. Sana izin verebilirim diyor. İçeriden senin ne istiyorsan kendin almana. İşte get humidity, get temperature, get heat index falan filan. But won't that be less convenient for you? If you have to come to me every time you want something, you might have to make multiple method calls to get all the state that you want. Birden fazla diyor yöntem çağrısı yapmak zorunda kalacaksın. Atıyorum 100.000 tane şeye ihtiyacın varsa 100.000 tane yöntem çağırman lazım. Get temperature, get humidity, get heat index, get bilmem ne. Halbuki diyor ben sana paket olarak vereyim hepsini diyor. Al da diyor sen ne istersen kullan ondan sonra. Both sides have some strong arguments there. Both sides have reasonable reasons. They have reasonable foundation for their arguments. And there is no clear answer on whether we should be using the push strategy or the pull strategy when we are dealing with observers and subjects. So basically the end decision, it depends on the context. It depends on the needs of your particular application. Not only that, but in Java, the observer pattern is so, in fact, in the object-oriented world, the observer pattern is so often encountered that Java provides it already implemented up to a certain degree. So you don't have to code it from scratch. What Java provides is the observable class and the observer interface. Now be careful, instead of a subject, Java calls the subject observable. And it is not an interface, but a direct class, a concrete class, whereas the observer is still an interface. What does the observable class contain? It contains, of course, add observer, delete observer, notify observers, but additionally, it also contains something called set changed. This doesn't look familiar. We will get to that. So if we were to use Java's own implementation of the observer design pattern in order to solve our weather problem, we would be extending the observable class through the weather data class, which would mean that we only have get temperature, get humidity, get pressure, but all the other 4 methods would be inherited from the observable class. So what is the advantage of this? Well, the advantage is that we don't have to code add observer, delete observer, notify observers. I mean, you need to do that for every observer paradigm anyhow. So there is no need to code that part. So it saves us some time. Whereas in the case of the observer, well, in that case, there isn't really anything here that is saving us time. We only have directly the interface, and all we have to do is just implement that interface and fill in the missing update method. Any questions about the Java version of the observer design pattern? Okay, class. Now, how exactly does it work? Some details. Now, naturally, of course, you will need to add your observers into the observable class. However, the main difference with respect to the previous stuff that we saw is this set changed method right here. Now, this is something that we didn't encounter before, and it is also inherited from the observable class. So what are we supposed to do with set changed? Now, notify observers. Now here, of course, there isn't anything called automatically. So it is up to the observable to decide when to call notify observers, depending on what is being observed. So the observer, in order to receive notifications, it uses the update method, but differently from before, it has 2 parameters. It has the observable O and the object argument. So the observable is basically the subject that sent the notification, and it additionally receives an object argument which contains all the data that the observable is passing to the observer. Dolayısıyla hani bütün aktardığımız veriler tek bir nesne olarak, tek bir nesne referansı olarak paketlenmiş durumda. Şimdi bunun içerisinde kim bilir neler neler var. Humidity, temperature, pressure vesaire vesaire. Dolayısıyla bu yapıyla with this design, you can use either the push strategy or the pull strategy. If you want to use the push strategy, then it is the observer that will take all the data from inside this object, this arg second parameter. If on the other hand, you want to use the pull strategy, you can use the observable subject, the observable reference, and call the method that corresponds to the data that you want to pull. So this design can be used with both pull and push strategies. Now, what about this set change method? We didn't need that before. Now, what is the issue? Well, how does it work exactly? Now, the set change method is critical. You need to really understand what it does and why it does it. The set change method is used to signify that the state has changed. Yani bir yenilik var, bir değişiklik var. And that notify observers, when it is called, should update its observers. If notify observers is called without first calling set changed, the observers will not be notified. Yani arkada çalışan ne arkadaşlar? Anlatıda çalışan böyle bir şey. Check this out. What the set changed method does is very simply, it just sets a Boolean variable as true. And in notify observers, very interestingly, inside the observable, it first checks whether this flag is true, if it is set, and only if it is set, it notifies every observer on the list. If it is not notified, if it is not set, nobody is notified. Now, why do we have this? Why is this necessary? Why add one more step that complicates things? Well, the answer is very easy. This gives us an amount, a certain level of control on when exactly to notify the observers and when not. For example, could there be cases where there is exactly a change in the state, but you don't want the observers to be notified? Well, of course. A classic example is, for instance, when the weather station makes very small measurement updates. For instance, let's say that the temperature was 25 degrees, and then there was a modification. The temperature increased, and now it is 25.001 degrees. Now, that is indeed a change. 25 is not equal to 25.001. However, it is not a noticeable difference. It is not a significant difference for the client. So what do we do? For instance, by using set changed, every time that there is a change, we could control whether that change is worthy of notifying the observers. And if it is, then we can call set change and then call notify observers. Otherwise, you simply don't call set changed, and that's it. So all it does, all that set change does is it enables us to exercise certain level of control on when those updates should be sent to the observers and when not. That's the whole idea. Let's look at an example. So here we have the observable and the observer from the java.util package. The weather data, of course, extends the observable. So public weather data, as before, well, basically it is an empty constructor now. Why? Because we no longer need to maintain an array list containing the observers, because that is taken care of in the observable class. So it is an empty constructor. Question: in Java, if you do not add an empty constructor, does Java provide it for you?
Now you asked, I'm not so sure.
Yes, it does. If you do not add a constructor, if you have no constructors, sorry, I'm correcting that. If you have no constructors, Java adds automatically an empty constructor. So you can still create a an object of your class. But if you do have a constructor that accepts certain arguments, then it will not add automatically an empty constructor. So it is only added automatically in the case where you have no constructor. Okay, so long story short, adding this and not writing it at all would make no difference because it would have been added automatically anyhow. So let's look at the measurements changed method. Now it is a bit different. It first calls set changed, and then it calls notify observers. Now, if we hadn't called set changed, in order to set change, in order to set it as true, the flag variable, notify observers would not notify anyone. So it is necessary to first call set changed and then notify observers. And it is up to us inside this method to make all necessary controls, etc., in order to make sure that it is worthy of notifying the observers. I mean, that's how the library works. Yeah. Any questions about this? Okay. Now let's go back to the display and see how it changes in the case of the Java model. So once again, we have the current conditions display class, which of course will implement the observer and the display element interfaces. Now, differently than before, we are also including the observable reference inside it. The constructor will receive the observable from the outside, and as soon as it receives it, the observer registers itself with the observable. So observable dot add observer. And what about the update? Now the update has, of course, two parameters. It makes sure that OBS is a reference of weather data because it could be an observable of any type, but we are only interested in observables of the real type weather data. And if it is a weather data, it casts it and only takes the get temperature and get humidity values. Now, is this the push strategy or the pull strategy?
Pull strategy.
Yes, it is the pull strategy. Now, let's get past this part. Running the new code. Now here it says don't depend on the evaluation of observer notifications. Basically, it says that when you have 10 different observers, you should never rely on the order with which you called notify observer. So you have, for instance, 10 different objects, 10 observers. You should never assume that just because you called observer 1, just because you notified observer 1 before observer 2, that observer 1 will get to run first. So no such assumptions. You already know that from your system programming course. Never assume anything when you're dealing with multiple threads when it comes to the order of execution. And what about the dark side of Java util observable? I mean, if it is so great, why isn't everyone using it? Now, observable is a class. It is not an interface. And that already is a disadvantage because any class that extends observable, that means it has already used its only single extension quota. So it can no longer extend any other class. So if you subclass observable, that's it. There is no other class that you can subclass. You are limited in the case of Java. So that is an important flexibility that we lose the moment that we use Java util observable. But then again, it has to be a class in order to contain all the code, including add observer, remove observer, notify, etc., etc. Other places where you will encounter the observer design pattern, well, very actively you will encounter it if you work with Java Swing or Java FX. So basically when you work with graphical user interfaces, because there the main problem is there needs to be a communication between the graphical components such as buttons, text fields, sliders, and so on, and the code that is listening to them. So let's say that there is a button on your graphical interface, and you want that, and you want the moment that it is pressed, a certain function to be executed. So a class represents the button. There is another class represents the code that needs to be executed when that button is pressed. So this is a observer observable or observer subject situation where you can actually use the observer paradigm. How does it happen? Well, basically what you need is an action listener that lets you listen in on the type of actions that might occur on the button, like a button press. And how does the observer work in this case? Well, it's basically very easy. Here we go. Let's look at the swing observer example. Here, for instance, we have a frame, a Java frame. So this is an example of a Java swing from the old times. And here we have a button. Now the button here represents the subject, the observable. And here we have the observers. So basically the code that is supposed to be executed when the button is pressed. So here we add the observers. This is observer 1, angel listener, and this is another observer, devil listener. So every time that the button is pressed, the subject, the button, J button, notifies the two observers, angel listener and devil listener, to execute their code. It is as simple as that. And you can modify, you can add new listeners, you can remove listeners at runtime even. And this is a very important flexibility in the context of Java Swing. Yani dinamik bir şekilde arkadaşlar grafik arayüzünüzden belli bir düğmeye basıldığında hangi listener'ların çalışacağını, çalışmayacağını dinamik bir şekilde kaldırma, ekleme olanağını size sağlıyor bu durumda. Doğrudan şeyin observer observable veya observer tasarım örtüsünün doğrudan bir gerçeklemesi. Düşün yani her düğmeye bastığında herhangi bir grafik arayüzünde bir şeyle etkileşime geçtiğinde arkada bu meret varmış meğer. En azından şey olarak, tasarım olarak. Yes, the observer. And that's it basically. Observer'la ilgili arkadaşlar söyleyeceklerimiz bu kadar. And that brings us to the decorator. Any questions so far?
Hocam ben bir şey sorabilir miyim?
Tabii buyurun.
Konuya geçmeden önce.
Tabii ki.
Bu hocam Netflix gibi sitelerde üye olduğumuz zaman bu kullanıcıları da observer gibi düşünebilir miyiz?
Tabii ki düşünebiliriz. Tabii ki düşünebiliriz Akif Bey. Yani sonuçta ne yapıyor Netflix veya onun gibi benzer onlara üye olduğunuz takdirde hani üyelikten de öte hani size aktarması gereken belli bir bilgi var, belli bir veri var. Nedir o veri? İşte atıyorum her hafta yeni işte diziler çıkıyor, yeni filmler çıkıyor falan filan. Dolayısıyla ne yapıyor? Abi diyor benim diyor toplam diyor ne kadar diyor şimdi mesela atıyorum her cuma mesela güncellenecek. İşte bugün kaç tane şey çıktı? Türkiye için 50 tane yeni film çıktı, 20 tane yeni dizi çıktı mesela. Onları şeylere, üyelere, kullanıcılara, abonelere aktarması gerekiyor. Dolayısıyla orada ne yapabilir? Siz her Netflix'e girdiğinizde orada artık ya push ya da pull stratejisiyle o yeni çıkan diziler, filmler sizin ekranınıza aktarılmış oluyor. Hatta orada daha da ayrıntılı bir kontrol var. Sizin o hesabınızda özellikle sizin zevkleriniz neyse işte atıyorum macera filmleridir, dramlardır, komedilerdir falan filan. Hangileri ise ona göre aralarından seçiyor size en çok yönelik olanları. Yani ek bir filtreleme falan bile daha var orada. Ama mesela sizinle alakalı olmayan, sizin zevklerinize uygun olmayan şeyler varsa orada tamamen o zaman hiçbir notification bile gelmeyebilir. Hiçbir update çalışmayabilir. Çünkü bakıyor baştan da arkadaş burada Akif'in keyfine uygun, onun zevkine uygun yeni filmler, diziler var mı? Yok mu? O zaman Akif'e haber verme. Ne zaman ki onun zevkine uygun şeyler olacak o zaman haber veririz. Tam o yani set change'in kullanılacağı yerler.
Anladım hocam. Teşekkürler. Sağ olun.
Şimdi arkadaşlar sıra geliyor kahve örneğimize. Yanlış hatırlamıyorsam bu kahveli olandı. Ah yes, Starbucks coffee. Bir bayağı kasmış bunlar da uydurmaya. Okay class, a new design pattern. Now this time it is no longer a behavioral design pattern. Instead, it is a structural design pattern. The decorator. Bunun arkadaşlar Türkçesi ne olsun? Decorator. Herkes uykuya daldı herhalde. Yemek ağır bastı. So we continue with the decorator. Now, the decorator is a very powerful design pattern, similarly to the observer design pattern. And it will show you how you can actually add new responsibilities to objects, either yours or other people's objects. So basically code that has been implemented by other people and code that has been compiled even, derlenmiş olan kapalı koddan söz ediyorum. It allows you to add new responsibilities to these objects without making any code changes to the underlying classes. Sınıflara, nesnelere, ister sizin, ister başkası tarafından kodlanmış olan, hatta kapalı kod bile olsa olan nesnelere yeni sorumluluklar yüklemenize olanak sağlayan bir tasarım örüntüsünden söz ediyoruz arkadaşlar. Oldukça kuvvetli bir şey yani. Kullanacağımız ana teknikte, the main technique that we will be using in order to achieve this is composition. Not inheritance, but composition. Now, our context is very simple. It's Starbucks Coffee. It's a company that made a name for itself as the fastest growing coffee shop around. And because they have grown so quickly, they are scrambling to update their ordering systems to match their beverage offerings. Okay, so they are growing very fast. They offer many different kinds of new beverages, and they have difficulties keeping up as far as their IT infrastructure is concerned. Now, when they first went into business, the situation was very simple. They had an abstract class beverage. I can tell that it is abstract because it is written metallic, which has a certain description, such as a string, something. An abstract cost method. It is abstract because an abstract drink, an abstract beverage cannot have an actual cost. And then we have the subclasses, the actual beverages that extend the beverage abstract class and implement the abstract cost method. So initially they only had 4 types of coffee: house blend, dark roast, decaf, and espresso. And each of them has, of course, its own cost method. However, as time went on, in addition to the coffee, they allowed people to also ask for several condiments, like steamed milk, soya, mocha, so chocolate basically, and have it all topped off with whipped milk. Now, each of these combinations, in this case, of course, has a different cost. And each of them, in this case, if we continue with the initial design, is represented as a separate individual subclass that extends the original abstract class. And of course, this has led to an explosion of classes. Now, at this point, I would like to ask you, can we use the hash map technique that we used with the guitar example of Rick during our first week? Can we use a hash map in order to reduce the number of classes? Yes, no? I'll ask the question and I will answer it myself. No, we cannot use the hash map technique that we used with Rick's Guitar Shop, because at Rick's Guitar Shop, we had different classes representing different instruments, yet those classes didn't have different behaviors. They only had different properties. Whereas here, even though they have different properties, since each class represents a different combination, they also have additionally a different cost method. So the cost is something that returns a value depending on the particular combination of condiments on that coffee. So depending on whether it is decaf or house blend, whether it has mocha or steamed milk, or maybe it has 2 times mocha, and so on. So we cannot use the hash map technique because the cost is something dynamic, calculated based on the condiments that it contains. So we need a different solution for this. And plus, if you have 5, 6, 7, 8, 9, 10 different such parameters, so the condiments, type of coffee, and so on, you can have a very, very high number of total combinations in order to include in your hash map. So it is not practical to use that technique. Are we clear on this? Neden hash map ile bu işin içinden çıkamayacağımızı anlatabildim mi arkadaşlar?
Hocam ben anlamadım tam olarak. Yani parametre çok diye çıkamayız dediniz ama onu tam anlayamadım.
Kimdi konuşan?
Doruk hocam anlamadım pardon.
Doruk Bey, düşünün ki bu olayı şimdi hash map ile çözmeye çalışıyoruz. Yani bütün bu sınıfları yok edip sadece somut bir beverage sınıfında şey tutmak istiyorum. Bir hash map içerisinde şey tutuyorum. İşte kahvenin türü, hangi türden, üzerinde de şeylerin olduğunu, üzerindeki kondimentler dediği, ne denir onlara? Ekler mi? İşte sütü var mı, çikolatası var mı vesaire vesaire. Şimdi orada kaç tane parametrem var? Bir, kahvenin türü var. İşte süt var mı yok mu? Çikolata var mı yok mu? İşte soya var mı yok mu? Vesaire vesaire. Şimdi bunlar sayısı yüksek olabilir. 5 olur, 6 olur, 10 olur, 20 olur. Bunların hepsinin farklı farklı kombinasyonlarını almaya kalkarsak orada baya bir patlama olacak o hash map'teki satır sayısında. Ama sadece parametre sayısından da öte her parametreden birden fazla da olabilir. Örneğin öyle kahve olabilir ki işte house blend coffee artı çikolata artı krema artı çikolata artı çikolata. Yani 3 çikolata 1 krema artı kahve şeklinde. Şimdi onların her biri için, her olası kombinasyon için ben hash map'te ayrı bir satır tutamam. Ayrı bir satır tutarsam onların o zaman tabii fiyatını da hesaplayabilirim. Ayrı ayrı onu da kaydederim içeriye. İşte atıyorum X kahvesi yanına süt, yanına çikolata olursa fiyatı 10 lira. Y kahvesi yanına çikolata, yanına soya olursa 15 lira. İyi de ya şimdi müşteri şey isterse X kahvesi artı çikolata artı 2 süt. İyi de hash map'te öyle bir şey yok. İyi de ben müşterinin isteyebileceği olası tüm kombinasyonları zaten hash map'e kaydedemem ki. Hani ne kaydedersen kaydet adam günün birinde gelir arızalı tipin biri abi ben şey istiyorum der. 1 kahve 3 süt oranında istiyorum. İyi de hash map'te öyle bir kayıt yok. Şimdi onun fiyatı kaç? Elimizde patladı. Durum bu. O yüzden hani olayı hash map'e indirgeyemiyoruz çünkü çok yüksek sayıda kombinasyon var işin içinde veya olabilir daha doğrusu. Bu basit örnekte dahi.
Anladım hocam teşekkürler.
So what do we do? Now it is pretty obvious that Starbucks has created a maintenance nightmare for themselves. So what happens when the price of milk goes up? So that means if you had a hash map, you would have to update a lot of values in there. So what do they do when they add a new caramel topping? So you have designed the entire hash map or the database with the prices without caramel taken into account. So the moment that you add a new kind of a topping, there is a whole new set of combinations that you need to add to your hash map. So that's silly. I mean, that's not how you deal with these problems. And this lady here says, this is stupid. Why do we need all these classes? Can't we just use instance variables and inheritance in the superclass to keep track of the condiments? What does she mean exactly? Let's look at it. We start with the beverage base class, the abstract class, and we add instance variables. So very simply, we are trying to use a single class in order to model the possibilities. So whether it has milk or not, soya or not, mocha or not, whip or not, and we try to keep the cost of each of these in a single central location. So these are our Boolean variables. So milk or not, soya or not, true, false, mocha, true, false, whip, true, false. And when you try to calculate the cost of a beverage, it will very simply look at whether it has milk or not. If it has milk, add the cost of milk. If it has soya, add the cost of soya. If it has mocha, no, it doesn't. So don't add anything. If it has whip, yes, add the price, the cost of whip. You get the total, and that's the cost. So can we do it that way? And where exactly is the inheritance? Now the inheritance is, of course, on the type of the coffee. So the superclass cost will calculate the costs for all of the condiments, while the overridden cost in the subclasses will extend that functionality to include the costs for the specific beverage type. For example, bana bu kombinasyonlarda arkadaşlar bir tane içecek söyler misiniz şimdi bu 4 taneyi kullanan kısmen de olsa belli bir kahve türü için?
Espresso.
Okay, espresso coffee. Which condiments?
No milk, no soy, no mocha, no whip.
Okay, so espresso with milk, basically.
Okay.
Okay, so the cost in the superclass will add in the cost of the milk, since it contains milk. How do I know that it contains milk? Well, I call has milk. If it returns true, well, in that case, include in the cost the price of milk. And that's it. That's all we return as the cost method of the superclass. But when the subclass calls the cost method, so the espresso class, it will first call super.cost to get the price of the condiments, and it will add to it the cost of the espresso, the base cost of espresso coffee. And the total will be the actual final cost of the product. So that's simple enough, but so we have how many classes? 1, 2, 3, 4, 5. So is it done? Have we solved the problem? What do you think? Is
Yes.
it elegant? Yes, we have
Yes.
solved it.
The polymorphic model is much more convenient.
So what happens when the customer wants double milk? Because the current model only supports an on-off type of a system. So either it has milk or not, soya or not, mocha or not, whip or not. So there comes a customer who says, I want an espresso with double milk and double mocha. And unfortunately, we have to say to him, I'm sorry, sir, the IT system that we have doesn't support double condiments. So we cannot sell that to you.
We
I can
add-
only
we
give
could
you a
add-
single milk.
We could add a parameter to the functions.
Yes.
Yeah, we add a parameter to these functions that has milk, that has blah blah blah functions, and then we could determine an amount to be added. Yeah, we can just modify the abstract class, and we'll be done.
And where would that parameter come from? So who gives that parameter? How is it used? So let's say that, let's go from the initial example, espresso with milk. So let's say that it is double milk now.
Okay.
Okay, so I call the cost method of espresso. So what happens?
Before the cost method, maybe if we call it with a constructor, at least we know it exists somewhere.
Okay.
And then when we call the cost, it's an overridden cost method that could calculate the new specification.
So the double portion of milk, you gave it at the constructor. So the constructor of the espresso class receives how many portions of milk? So in that case, you will need one parameter for each of the condiments.
Ah,
So
yes,
one
yes.
parameter representing how many times milk, how many times soya, how many times mocha, how many times whip.
Yeah.
And if by any chance somebody in the future adds one more type of condiment, such as caramel, in that case
Re-implement.
you will have to update all of those constructors.
Right, yeah.
Which is not exactly a disaster, since we don't have 10,000 classes. We only have 4 classes, 4 types of coffee. But still,
Still
I
a
mean,
hassle.
yeah, still it's not as elegant as it could be.
Right.
But that could be a solution too. I mean, if we knew that the types of condiments are fixed, well, in that case, you have 4 parameters, four numerical parameters for the espresso that you transfer to the superclass, and the superclass uses those parameters in order to calculate the cost of the condiments. It is a possibility. So let's see, how can we do this any better? And this guy says, I'm not so sure. I can see some potential problems with this approach by thinking about how the design might need to change in the future. So how can it cause any trouble? Price changes for condiments will force us to alter existing code. Okay. New condiments will force us to add new methods and alter the cost method in the superclass. We may have new beverages, so additional beverages such as iced tea. And that means those additional beverages will have to support all of those condiments. So it will be possible to add, for instance, whip to iced tea, which doesn't really make sense. So this system is assuming, this design is assuming that all of the subclasses can use any of those condiments. So the moment that you add iced tea, the entire system breaks down, unfortunately. And plus, as we have mentioned previously, what if a customer wants a double mocha? So as you can see, this design is very, very limited. We need something better. Okay, let's go to the better part. So what does the guru, what does the master say? The master says, Grasshopper, it has been some time since our last meeting. Have you been deep in meditation on inheritance? Yes, master. While inheritance is powerful, I have learned that it doesn't always lead to the most flexible or maintainable designs. This is good. So tell me, my student, how then will you achieve reuse if not through inheritance? Master, I have learned there are ways of inheriting behavior at runtime through composition and delegation. When I inherit behavior by subclassing, that behavior is set statically at compile time. In addition, all subclasses must inherit the same behavior, just like they inherit his whip, etc., even though T doesn't accept whip, or at least it should. If, however, I can extend an object's behavior through composition, then I can do this dynamically at runtime. Yes, very good, Grasshopper. You are beginning to see the power of composition. It is possible for me to add multiple new responsibilities to objects through this technique, including responsibilities that were not even thought of by the designer of the superclass. And I don't have to touch their code. Now, this is really interesting. Without touching the original code, adding responsibilities to it. Dynamic object composition. Okay, how do we do that? The open-closed principle. Classes should be open for extension, but closed for modification. Now, these are really conflicting concepts here. Our goal is to allow classes to be easily extended to incorporate new behavior without modifying existing code. So how do we accomplish this? That's the main issue. And here there is a nice example. Open for extension and closed for modification. That sounds very contradictory. How can a design be both? How can it be both open and closed? It certainly sounds contradictory at first. After all, the less modifiable something is, the harder it is to extend. As it turns out, though, there are some clever object-oriented techniques for allowing systems to be extended, even if we can't change the underlying code, such as the observer pattern. By adding new observers, we can extend the subject at any time without adding code to the subject. That's interesting, but still very vague, still too abstract. Now, let's continue. Let's look at the decorator pattern. Now, here's what we will do instead. We will start with a beverage, and we will decorate it with condiments at runtime. Decorate it with condiments at runtime. We will start with a base object, such as a dark roast or espresso or houseplant or whatever, and decorate it with whatever we want to, dynamically. Give it a mocha decoration, give it a whip decoration, and so on and so on. And finally, we will call the cost method, and the cost method will check all the dynamic decorations, and it will use delegation in order to calculate the total price. But how exactly will that happen? Let's look at the visual, and this is the part where it is explained. Now, this is the base object, so a dark roast object, which contains the base cost method. What does this cost method calculate? The base price of a dark roast object. Espresso ise sade espresso'nun fiyatı. Okay. Say the customer now wants mocha. So what do? You create a mocha object and wrap it around the dark roast object. Now, additionally, of course, the customer might ask for whip. The whip object is created and it surrounds the mocha object, which surrounds the dark roast object. And if finally the client or the user tries to calculate the total cost, it first calls the cost of the outer, dıştaki, the outer class, which will call the cost of the inner class, which will call the cost of the inner class all the way to the base class. The base class will return the cost of dark roast, 0.99 cents. The outer class will return its own cost, so the cost of mocha, 20 cents, plus the 0.99 of the dark roast. And this cost will return 0.99 plus 0.20 plus the cost of the whip. So in total, $1.29 for a dark roast with mocha and whip. And as you can guess, this combination is completely arbitrary. It could have been mocha dark roast. It could have been whip dark roast. It could have been çaya ne konur ya? What do you add to tea?
Mint.
Mint. It could have been mint, and iced tea, and so on. So it gives us complete 100% flexibility to produce any arbitrary combination of condiments. This is great. Plus, it doesn't even require us to have coded the dark roast base class. As long as we know that it has a cost method, the dark roast object could have been created from a class that has been coded by somebody else. We don't have to modify the dark roast class in order to establish this mechanism, in order to achieve this design. All we have to know is that it has a certain cost method that returns the cost. That is enough for us. And now we have enriched, geliştirdik, zenginleştirdik. We have extended, enriched the dark roast class so that it can be decorated with mocha and whip. The iced tea can be decorated with mint and so on, etc. without changing the original classes. That's the beauty of it. So what do we know?
Sir.
Yes?
Excuse me. Okay, this is all well and good, but how do we make the iced tea, for example, in this model?
The same way that you make a dark roast.
But the iced tea's ingredients don't exist.
Iced tea you mean the condiments?
Yeah, we talked about potential problems earlier. One of them was adding
yes.
a new beverage.
Yes. So one of those problems was that if we use, sorry, let me get there. If we use this original design and we extend the base class, the beverage, by saying that iced tea is also a beverage, which is not wrong, it is correct. Iced tea is also a beverage. The problem is that it inherits all of these condiments. So it becomes possible, not necessary, but it becomes possible to add milk, soya, mocha, and even whip to iced tea, which shouldn't be possible. Whereas in this design, we have full flexibility to add whatever we want to. Now, does this mean that we can still add mocha to iced tea? Yes, we can. But at least it doesn't mean that the iced tea object will inherit necessarily his milk, his mocha, and so on. Now, have we created the mint class? No, not yet. We haven't even created the iced tea class yet. So first, let's look at the design so that it will become a bit clearer. But before we come to the design, let's look at these bullet points. 1. Decorators have the same supertype as the objects they decorate. This is important. The decorators, so whip, mocha, mint, they have to have the same supertype as the objects, so dark roast, iced tea, that they decorate. Otherwise, you cannot have this Russian doll mechanism where you put one object inside the other. 2, you can use one or more decorators to wrap an object. In fact, you can use n decorators to wrap an object. 3, given that the decorator has the same supertype as the object it decorates, so whip will have the same supertype as dark roast, but one of them is a condiment and the other one is a beverage. That means we can pass around a decorated object in place of the original wrapped object. Very interesting. Key point, the decorator adds its own behavior either before and or after delegating to the object it decorates to do the rest of the job. And finally, objects can be decorated at any time, so dynamically at runtime with as many decorators as we like. Now, how do these bullet points translate to a design? Official definition, the decorator pattern attaches additional responsibilities to an object dynamically. Decorators provide a flexible alternative to subclassing for extending functionality. Kalıtım yerine arkadaşlar bir nesnenin yeni özellikler katmak için güzel, esnek bir alternatif. How does it work? Let's look at this design. Now, this is the generic form. So we have component, which is subclassed by 2 classes. Concrete component and decorator. Now, we still have inheritance for the necessary parts, but we are using composition in order to decorate them. Now, component is the base class, and it is abstract, as you can see from the italic form. So this one will be, in this case, well, we will see what it is in the following slide. So component is the base class. What is important is that both the decorator classes, so the condiments, whip, soya, milk, and so on, which extend the decorator class, as well as the base class, so the concrete component, which represents iced tea, dark roast, and so on, extend the same base class. This is what we meant by they need to have, right here, they need to have the same supertype as the objects that they decorate. So both the base class and the condiments have the same supertype component. But what is interesting is that you can see there is an additional arrow here. There is an additional arrow right here. So the decorator is a component, but the decorator also has a component. And it is thanks to the second arrow that we can wrap these objects one inside the other. So here, for instance, under the decorator, we have 2, for example, instances, 2 classes. Yeah, we have 2 classes. Now, let's look at the actual example now. So here we have at the top the base class component beverage. We have the concrete beverages, so house blend, dark roast. So these are the base classes in this case. In our case, they're just the 4 types of coffee. But you could have, for instance, iced tea in this case, or hot tea. There would be beverages extending the abstract beverage class. And what is interesting is that the condiment decorator, which is the common supertype of all the condiments, milk, mocha, soya, whip, or mint, and so on, they all extend the same condiment decorator. And the critical part is that in addition to that, we have this composition relation, which means a condiment decorator is a beverage. So here is the is relation, but also has a beverage inside it. And here is the beverage that it contains. So mocha contains a beverage. So this means mocha wraps around a beverage object. But what is this beverage object? It could be anything. It could be a base class, such as dark roast. It could be another condiment decorator, such as a dark roast wrapped with soya. So if you wrap it with mocha, it will be a mocha soya dark roast. Mr. Alp, has your question been answered now that you have seen the design?
Absolutely. Yeah.
Okay. Any questions about this design? Mesela gördüğünüz gibi şey değil ya. Yani kuantum fiziği değil yani. Alt üstü ekstradan bir ok ekledik yani. Okay, so how about the calculation of the cost? Okay, so let's get past this. These are silly comments. New barista training. And this guy says, okay, I need for you to make me a double mocha soya latte with whip. Soya chocolato, micolato, macchiato. Okay, so how does it work? A double mocha with soya latte and whip. So basically inside it will have a what? A double mocha soya. So what is the coffee type here? Vallahi ben tarifi bile çözemedim ya. Double mocha, soya latte with
Mocha.
aslında çikolata istiyor adam yani. Kahve değil.
Mocha kahve değil mi hocam ya?
Mocha çikolata ya.
Çikolatalı kahve.
Nesquik.
Soya latte with ben şey bile benden barista olmaz. Ben adamın şeyini bile çözemedim. Siparişini bile çözemedim. Ama burada kahve mavi görmüyorum ben yani. Yani şuraya bakıyorum. Yani şeylerden hiçbiri yok. Kahvelerden hiçbiri yok. Yani adam ne istiyor? Mocha, double mocha istiyor. With soya and milk. Çünkü lattesi de var. Ha, bir de üstüne whip de istiyor değil mi?
Hocam
Yani sonuç
mokka'nın
olarak
kendisi bir kahve türü. Hani çikolatalı kahve. Karışım.
çikolatalı kahve.
Aynen.
Tamam abi öyle diyorsanız öyle olsun arkadaşlar. Sizi mi üzeceğim? Çikolatalı kahve olsun. Tamam. Çikolatalı kahve. Dolayısıyla kaç tane condiment var şimdi? Double mocha soya
Hayır.
latte with whip. Tamam. Yok bunu yapabiliriz ama ya. Bu şey değil. İmkansız değil yani. Şimdi double mocha ile başlayacağız. Zaten hangi sırayla gittiğinin bir önemi yok. Çünkü wrapper komütatif bir operasyon. Ha 1 artı 2, ha 2 artı 1. Dolayısıyla istediğin gibi başlayabilirsin buna. Sonuçta hesabı yaparken hangisini önce fiyatını hesapladığını hiçbir önemi yok. Dolayısıyla mocha nesnesini alırsın. Mocha, soya, latte, whip. Tamam. Gelelim buraya. Mesela mocha ile başlıyorsun. Mocha nedir? Condiment decorator nesnesi. Bir tane mocha ile başladın. Mocha'nın içinde ne olacak? Bir tane beverage. O beverage ne olsun? O da bir mocha olsun. Mocha'nın içinde mocha. Etti sana double mocha. İçine yine şey koyabilirsin. Beverage koyabilirsin. O da soya olsun. Soyaya milk koyabilirsin. Latte oldu. Whip de koyabilirsin. İç içe hepsi girebiliyor. Hepsi çünkü birer beverage'i içinde barındırabiliyor. Ama her beverage'de nedir? Her condiment decorator nedir? Her condiment decorator da aynı zamanda beverage olduğu için bunların içine bütün kondimentleri gömebiliyorum. O yüzden hiçbir problem yok. Arkadaşın istediği o abuk subuk tarifi bile yerine getirebiliyoruz yani. Hiç problem değil. Hepsi birer condiment decorator. Condiment decorator aynı zamanda da bir beverage. Dolayısıyla problem yok. Dolayısıyla en dışta whip olsa içeride soya, daha içeride latte, daha içeride mocha, daha içeride bir mocha daha. Oldu bitti. Hepsi birer condiment. Her condiment de bir beverage. What about the code? Kodu kolay. Public abstract class beverage. Well, it simply has a string description, which will be filled in later on, and a get description to access the string. And of course, an abstract cost, which will return the price of the beverage. The abstract class condiment decorator is also very simple. All it does is just extend the beverage. That's it. And the get description is of course abstract, which will need to be implemented by the subclasses in order to include whatever has been added to it. So coding the beverages, base classes, espresso, extends beverage, description espresso, and this is the base cost of an espresso, $1.99. Okay. House blend, very similarly, it has a different description and a different price. That's it. That's all there is to it. And now let's look at the condiments. Mocha. Public class mocha extends condiment decorator. And we know that condiment decorator extends beverage. So mocha is also a beverage. And it contains a beverage. So this is the arrow representing the composition. Mocha contains a beverage. So this beverage could be anything. It could be another condiment decorator. It could be a base beverage. It could be tea. It could be soya latte mocha house blend. It could be anything. And when somebody asks us the cost of this object, it is the base cost of the mocha plus whatever it is wrapping. İçine neyi sarmalıyorsa bütün onların toplam fiyatı artı bu mokanın fiyatı. Any questions about the condiment decorator?
The cost function looks almost like a recursive function, but it's not recursive.
Yes, it looks like a recursive function, but exactly, it is not recursive. Basically, it's just objects wrapping internally other objects. It is very similar to a recursive call without being recursive. So example, public class Starbucks coffee, public static void main. Let's see what we have here. So the base beverage is an espresso. If we print its description and its cost, well, we will see that it is just an espresso with a cost of $1.99. Now we are preparing a new beverage, beverage 2. Initially, it only contains dark roast. We are wrapping it with mocha, so now it is mocha dark roast. We are wrapping it again with mocha, so now it is double mocha dark roast. And we are finally wrapping it with a whip, and so now it is a double mocha dark roast with whip. And now we can print its description and its total cost. Or beverage 3, a house blend with soya, mocha, and whip. And here we have the total prices. Each one adds its own description. So the total description is the concatenated string of all the condiments and the base beverage. Nothing fancy, but it is an elegant design. That's what's beautiful about the decorator. So the main advantages: 1, it allows you to dynamically decorate objects however you see fit. 2, it allows you to decorate objects even if those objects were written by somebody else and you do not have access to their code. I mean, we never had to change in any way espresso, iced tea, dark roast, or house blend, and we can decorate them in any way we see fit. They could have been created by somebody else. They could have been binary classes to which we have no access in terms of source code. We can still decorate them with new things. That's incredible power in terms of design. Now there is a nice question here. I'm a little worried about code that might test for a specific concrete component, say house blend, and do something like issue a discount. Once I have wrapped the house blend with decorators, this isn't going to work anymore. So if, for instance, you have a discount only for one type of coffee, such as house blend, once you start wrapping it around with the decorators, you will not be able to exhibit that kind of class-specific behavior. Now, that is exactly right. If you have code that relies on the concrete components type, so some kind of piece of code that only works with house blend coffee, in that case, the decorators will break that code. As long as you only write code against the abstract component type, the use of decorators will remain transparent. However, once you start writing code against concrete components, you will want to rethink your application design and your use of decorators. So as long as you conform to the code according to an interface and not according to concrete classes, you will have no issues. But the moment that you start implementing coding specifically towards a certain concrete class, things start to break apart, unfortunately. Real world decorators. So an example of where decorators are used, something that you have already used, Java input output. Java input output. You might remember there were several classes in the Java library. Buffered input stream, file input stream, and so on and so on, when it came to reading actual files in Java. Well, that is a direct implementation, verbatim implementation of the decorator design pattern. Now, the base class is the input stream. Now, input stream can be anything. It could be buffered or not buffered. It could be returning binary data, ASCII data. It could be a file, or it could be a device. But in the base of it, in the core of it, it is basically just an input stream that is returning bytes. What those bytes represent, is it a string, a byte array, a file, That depends, but we can decorate it. We can include buffered reading or not buffered reading. We can include even a line number decoration, which adds the ability to count the line numbers as it reads data. So let's see how it works. So here we have the design. So this is the actual hierarchy of classes in Java. At the top, we can see the input stream, subclassed by file input stream, string buffer input stream, byte array input stream, and filter input stream. Now, this is the condiment decorator. This is the condiment decorator, which contains pushback input stream, buffered input stream, data input stream, line number input stream, which means you can use any of these four in order to decorate any of the above three. And of course, internally, the same input stream can have both buffered input stream and line number input stream. And in the core of it, it can have a string buffer input stream. So any combination is basically possible, just like with the double Mocha, etc., etc. Of course, it would make little sense to have a double buffered input stream. Example, how to write your own Java input-output decorator, since the decorator claims that we can decorate even binary classes, so classes that have been already compiled. So let's say that we want to have a new decorator from the input streams, which converts all uppercase characters to lowercase. Now, there is no such decorator in Java. So this is something that we will have to create right now. So very easy. Public class lowercase input stream extends filter input stream. So just like public class Mocha extends condiment decorator. Okay, let's see how easy it is to add a new condiment. So it will convert all uppercase letters to lowercase. So we have a constructor, lowercase input stream, which accepts an input stream, and very simply just calls the constructor of the superclass, just like Mocha accepts a beverage. So we need to have two methods. So these are the cost methods. So similarly to the cost methods in the condiment example. So one of them is read, which is supposed to read just a single byte. And one of them is read, which can read an arbitrary number of bytes. So len bytes specifically. And in both cases, what do? If we read a single character, we simply convert it to lowercase. Or if we read multiple characters, we convert each of them to lowercase, and that's it. And we return, as a result, the number of bytes that have been read. And how can we use it? Very easy. For instance, we create an input stream. How? So initially, at the core of it, we have a file input stream. So this is like, dark roast coffee or espresso. We decorate it with a buffered input stream. And on top of it, we decorate it with the decorator that we have just implemented, the lowercase input stream. So in total, we have a file input stream decorated with a buffer input stream, decorated with a lowercase input stream. And as soon as we read some characters from the file, so in.read until we reach the end of the file, and we print them out, we can see that it actually returns the lowercase characters right here. So this is what we read, a mixture of lowercase and uppercase characters, and it has been returned as only lowercase characters. Any questions about this? Okay. These are some silly examples. Let's get past that. And that brings us to the end of the decorator. So here we have the solution for that guy, for that barista, with the house blend wrapped by a soya, wrapped by double mocha, wrapped by whip, and so on and so on. Nothing fancy. Soya, etc. Beverage grande. So what happens if you have multiple sizes in their menu? Can you support that? Well, of course we can support that. So in the cost, you can very easily check the size of the beverage in order to modify the cost for the case of the soya condiment. So if you add a lot of soya, it's 0.20, medium amount of soya, or a little amount of soya, it's very easy to add flexibility depending on an additional property of the beverage. But of course, you need these if-else statements for each of these condiments. And that's all, class. As far as the decorator is concerned, that is all. Any questions about the decorator? Okay. Well, in that case, as I said, today our menu only has 2 design patterns. So it was 1 last week, 2 this week. And today or tomorrow, you will have your first homework. Since we have now seen 3 design patterns, we can do something interesting with them. The homework will be available via Moodle. So check your Moodle page. It will probably be available either tomorrow morning or tonight. And I expect you to implement it in Java, not C++. And the details will be in the document. You will probably have a week or 2 for your homework. And yeah, any questions? Okay, well, in that case, thank you for your attendance. That's all from me for today. And if everything goes all right, I will see you next week. Yes, Mr. Al?
Have a nice day. That's it.
Oh, thank you. You too. You too, class.
Thank you very much, sir. Have a nice day.
Thank you. Goodbye.